hope every one of you is doing well. Today we'll be looking at the Wilson cycle and its influence on climate. But before that, we would like to introduce ourselves. Myself, Anirban. I'm Ankush Coach.
I'm Shukdesh Ghosh.
And today we'll be looking at the definition of Wilson cycle, its how it works, and ultimately we'll be moving into its implication on the climate.
Hope you will are getting a learning experience and this.
And now deals with the Wilson cycle and its effect on climate. Now we have to first understand what is called Wilson cycle. The Wilson cycle is defined cyclical opening and closing of ocean crust due to movement of Earth's plate. Now we all know there are 7 plates in Earth. And what is less obvious is that they migrate across all over the Earth's surface in a very complex way. Now you are wondering why the Earth is movement, what is the force responsible for it. Do you want to mean at some point of time they all are together? Now let's try to find it.
Okay guys, so let's try to understand how the Wilson cycle works and where it derives its energy from. Well, to move the continents, you can well imagine how much energy it will require, right? So before that, let's try to understand where the Earth derives its energy to move the continents, to move the tectonic plates in short. Well, when the Earth formed 4.5 billion years ago, what it was a hot ball of molten lava. And over the years, as the Earth cooled, it left behind the crust as we see it today. But however, the Earth's interior, the mantle and the corresponding layers like the core, inner core and outer core are still hot, and evidences suggest that it is as hot as the sun's surface. Well, where does the heat come from? Well, when the Earth formed, it captured some of its primordial heat, and also the heat due to the radioactive decay of elements like uranium-235, uranium-238, and potassium-40. Okay. So when these elements decayed, it released heat, and that heat is still trapped in the Earth's mantle, and that's two of the reasons why the Earth is as hot as the sun's surface. Well, how the Wilson cycle works? Well, the continents, which are basically plates, move on the Earth's surfaces. I mean, on the Earth's mantle, which is molten, of course, and well, how does it start? How does Wilson cycle starts? Well, it basically starts with a thinning of the Earth's crust. Okay, so when that happens, a rising plume of hot magma comes out, and the continents move apart. I mean, the tectonic plates move apart. So when that happens, the point where the continents move apart, that basically gives rise to ocean basins, and the place where the continents collide, they give rise to mountains. Well, as researchers have found out, the Wilson cycle has brought the continents. The last time that the Wilson cycle brought the continents together was around 300 to 500 million years ago, and there will be a point of time in future where the continents will come back together. Presently, we see it. We very well know it how the continents are in its present configuration. Well, one point more that the continent was called Pangea. When all the continents collided and was united into a single landmass, it was known as Pangea.
Looked at what is the Wilson cycle and how it works. Now, it was first discovered by Wilson, and when he discovered it, he actually explained the various stages of the Wilson cycle. So let us look at them one by one. The first stage is called the embryonic stage of the Wilson cycle. Now, here the hot molten magma from within the mantle, it rises and it exerts extensional forces on the overlying crust. So the crust gradually starts to weaken at this point. Okay. So now we proceed to the next stage. The next stage is the young stage of the Wilson cycle. By now, an ocean has already formed and new oceanic crust starts to come up from within this point. Now, this actually is a continuity from the previous stage, because the Rift Valley which was present there gradually evolves into a parallel sided ocean. Very good present day example would be the Red Sea, which is situated between the Arabian Plate and the African plates. Next, we move on to the mature and subsequently to the subduction stage of the Wilson cycle. So, the mature stage. Initially, we had a parallel-sided narrow ocean. Now, gradually, the ocean basin starts to widen, and it develops into a major ocean. This spot is the region of intense volcanic activity, because hot magma rises up from here, and as it spreads out from here, it forms the new oceanic crust. This is also called the oceanic basalt. Further, as this process continues, the oceanic crust, away from the point of upwelling, we have the old oceanic crust, and as we move towards there, we have the new oceanic crust. So the old oceanic crust is much denser. So what happens over a period of time is that the continental crust and the oceanic crust, when they collide, the oceanic crust being denser, it subsides beneath the continental crust, and as it carries water along with it, it lowers the melting point of the rocks, and this in fact leads to volcanism. This type of volcanism is called Andean type of volcanism, and a good example would be the Pacific Ring of Fire, which I'm sure all of you might know. Then gradually we arrive at the terminal stage. The terminal stage actually is marked by contracting oceans, because when the rate of subduction overtakes the rate of formation of new oceanic crust, gradually the oceans in fact start to contract, and islands which were earlier present, they start forming new volcanoes. This also leads to active volcanism. In fact, a very good example of this type of volcanism would be volcanoes in and around the Mediterranean region. Finally, we arrive at the end stage of the Wilson cycle, where the oceanic crust has in fact completely gone down the continent, and the two continental crusts, which are both the sides of the oceanic crust, they now merge together, or rather they collide together to form a huge block mountain sort of structure. It's a fold mountain sort of structure, and a very good example would be the Himalayas, which were formed about 50 million years ago due to the convergence of the Eurasian plate and the Indian plate. Initially, so this way we in fact have arrived at the beginning of the Wilson cycle, because this actually links up with the very beginning. Now this region is weak, and in future this may again lead to further rifting, and the cycle will continue over and over again. So that's it. That's for the stages of the Wilson.
As you are well equipped with the knowledge of what is Wilson cycle, how it works, and its various stages, let us proceed into our main topic, which is the effect of Wilson cycle on climate. Well, before that, let us define what is climate. Well, climate may be defined as the average weather conditions over a given area over some period of time, and obviously there are several factors which affect climate. Since our main topic is Wilson cycle and its effect on climate, our primary focus will remain there. So let us discuss the effects. Well, ocean currents. Ocean currents, what do they do? Well, ocean currents being a very vital element of the earth, what it does is that it transfers energy and nutrients, and in turn affect the global climate. It basically transports heat energy from the equator towards the poles, and since the operation of the ocean currents depend on the distribution of land masses, and the distribution of land masses, which in turn is controlled by Wilson cycle, so we can say that Wilson cycle has a very direct and profound influence on the climate. Okay, but however, when the Pangea was in fact about 300 to 5 million years ago. Not much is known about how the ocean currents operated at that period of time, but yes, we can get a better understanding of how the ocean currents affect ocean currents and in turn how the Wilson cycle affects the global climate. We can look at some of the examples.
Yeah. So I'm going to cite a very good example of how the Wilson cycle has indeed influenced the Earth's climate. So when the Pangaea started to fragment, South America and Antarctica were together for quite some time. They were known as Gondwana, the southern part of the Pangaea, the supercontinent. Anyway, so when they gradually started to drift apart from each other, a channel opened up between them. This channel gradually widened to form what is now known as the Drake Passage. But as it started opening up, it allowed deep oceanic waters to encircle the Antarctic continent. This actually led to two effects. Locally, not only it cooled the Antarctic from temperate to the usual cold conditions that we know today, but globally it had even a greater influence. Scientists have actually predicted that the time when the dinosaurs existed, the climate was quite balmy and the atmosphere was very rich in carbon dioxide. So it's known as the greenhouse climate. But in fact, this opening up of the Drake Passage is cited as one of the factors which in fact caused the change from greenhouse climate to the icehouse climate as we are living in today. And Ankur will further cite more examples to in fact emphasize that the Wilson cycle has indeed changed the global climate.
Well, whatever Anirudh, my friend, whatever I said, wasn't it remarkable? Well, obviously yes, and let's we can do another example. Well, initially the northern and the southern American continents were far apart, but now as we know it, its present configuration tells us that they are joined. So what the Wilson cycle did was that initially when they were quite far apart, there existed an ocean current. Okay, that ocean current used to travel between the two continents, but the Wilson cycle caused the collision between the two continents, and what it did to the ocean current was that it forced the ocean current to move towards the northwestern part of Europe, and remarkably, it caused a very dramatic change in climate over there. Well, even now we can see that the northwestern part of Europe is warmer than its surrounding areas. Well, as the ocean current traveled towards the northwestern part, what it did was that it brought immense precipitation in the form of snow, and amazingly, this was an incident which caused the last ice age. Remarkable, isn't it?
My friend just talked how the Wilson cycle influence on ocean current. Now looks another way, which is also influence of our climate. Due to movements of plate, continent and continent generally crush each other, and that forms the mountain. The mountain like Himalayas are formed by this process. The winds generally block this kind of mountains, and then the wind starts to move upwards. And this side of this mountain, the rainfall is generally occur heavily. And the opposite side, that means the leeward side, the rainfall does not occur that much. That side is called the rain shadow side. When wind is crossed, it becomes dry. When it comes down, it's warm. This difference in the climate, this effect is called the orography effect. And now there is another influence on this kind of high mountain. The ice are generally formed in the above of this mountain, and the mountain strips and the slope are generally help to the movement of the glacier. On climate modeling on supercomputer has shown the mountain range is a positive feedback to lead to the ice age. This is another way that Wilson cycle affect on us our climate.
The Wilson cycle worth mentioning include increased volcanism in the mid-oceanic regions, which can in fact lead to high concentrations of carbon dioxide. This can in fact enhance the greenhouse effect. Another thing, the oceanic floor, which is newly generated from the mid-oceanic ridges, has more volume. so it can displace more water, and this can in fact lead to submerging of continental plates.
We approached the end of our video and we've discussed about the Wilson cycle, how it works, and eventually its effect on the climate. And honestly, it has been a learning experience for us, and I hope you guys find it useful. Thank you for watching.